Hi folks, welcome back to the 8.10 Partial Fractions lecture video series. So this will be the last video for this section. I will include all of the answers for the other problems that I don't do in the videos in the answer key. But right now we're going to go over a few that are more of the quadratic situation so we can see how those might be a little bit different, okay? So we're going to take a look at number 9 over here. And our strategy is still the same. We want to go ahead and set up our denominator and factor it. So I know my numerator, and I can factor the denominator to be x squared plus 1 times x squared plus 4. Okay? Now this means I have two irreducible quadratic factors. So instead of only having an a on the top, I need an ax plus b. We lose a degree. So if it's quadratic on the bottom, we need a linear on the top. The same thing is going to be true for the numerator of x squared plus 4. We're going to need another linear factor, so we'll call it cx plus d. Okay? So that means at the end, I'm going to have something over x squared plus 1 plus something over x squared plus 4. Okay, so we'll save a space for us to write our final answer. All right, so let's go ahead and set this up so we can find a common denominator. So my ax plus b is over x squared plus 1. So what's missing is the x squared plus 4. And I need that on the bottom as well as on the top. Plus my cx plus d is over x squared plus 4. So I know that this second fraction needs an x squared plus 1 over x squared plus 1. All right. Are all my denominators the same? Yes, they are. So I can get rid of them. All right, let's see what we have left. Okay. Now I have on this side, I have x squared plus 3x plus 1 equals this term plus the other numerator. Now, the trick we've been using about, well, let's pick some numbers for x and make some of the terms go away, is that doesn't always work for us, okay? So if I think about this, what number can I plug in for x to make this 0? And unfortunately, there's no real number that can make that true. And what if I check this one? A real number that makes that equal to 0? Well, there isn't one. And so what I'm going to have to do is actually multiply things out like I did in the very first video and create a system of equations. So let's FOIL. Whoop. All right, I've got x squared plus 3x plus 1 equals ax to the, oh, that's not a squared, ax cubed plus 4ax plus bx squared plus 4b. That all comes from the first term. Plus, the second two multiplied together gives me cx cubed plus cx plus dx squared plus d. Now, I'll notice that there are no terms on the left-hand side with a cubed, so I'm going to write plus 0x cubed. So I know it's a 0 there, okay? And now I'm going to find equations with my sort of like terms. All right, let's see what we have. Which terms have a cube? 0 equals a plus c. There's my first equation. 0 equals a plus c. All right, let's find our second equation. 1x squared equals bx squared plus dx, or 1 equals b plus d. All right, let's find our third equation. 3x equals 4ax plus cx, or 3 equals 4a plus c. All right, what's our last equation here? We have 1 equals 4b plus d. Okay. So I know this is a lot of mini equations, but we can kind of break them up into the equations that have a and c and the equations that have b and d. So let's take the ones that have a and c. I like the method of elimination, so I'm going to multiply the top equation by -1. So I get 0 equals -a minus c, and then I'm going to add that to the second equation. 3 equals 4a plus c. That will give me 3 equals 3a, or a equals 1. All right, now once we have a, we can find c. If a equals 1, then c equals -1. And I just plugged it back into this equation. All right, let's do the same thing with the two equations that have b and d. So if I take these two, I'm going to multiply the top one by -1 again. So -1 equals -b minus d. And I add that to the bottom. 1 equals 4b plus d. And I'm going to get 0 equals 3b, or b equals 0. Now I want to find my d. Well, if b equals 0, then d has to equal 1 according to this equation right here. All right, so a little bit longer, but I've got all 4 of my letters, so let's put them back in. So ax plus b will just give me 1x plus 0. And cx plus d will give me -1x plus 1. And you're welcome to leave it like that, or you can clean it up a little bit and say x over x squared plus 1 minus x minus 1 over x squared plus 4. Okay? Either version would be fine. All right, let's see if we can't squeeze in one more practice problem here. And let's take a look at number 10. All right, so with number 10, I have a linear factor and I have an irreducible quadratic. So that means I'm going to need a over 2x minus 1 plus bx plus c, a linear one, over the irreducible quadratic. And so let's save some space for our final answer. Okay. All right, let's find that common denominator. So I'm going to go ahead and say that x squared minus x minus 21 over 2x minus 1 times x squared plus 4 equals a times x squared plus 4 over 2x minus 1 times x squared plus 4. Okay, so that makes my common denominator, plus bx plus c times 2x minus 1 over x squared plus 4 times 2x minus 1. All the denominators are the same, so get rid of them. And let's see what we have left. x squared minus x minus 21 equals, it is going to be a situation that we need to FOIL out, so I'm just going to do that right now. Ax squared plus 4a plus 2bx squared minus bx plus 2cx minus c. And now I'm going to match up my like terms to make 3 different equations. All right. So I have x squared equals ax squared plus 2bx squared. That is going to give me 1 equals a plus 2b. All right, negative x equals negative bx plus 2cx. That gives me negative 1 equals negative b plus 2c. All right, what about that last equation? Well, we have negative 21 equals 4a minus c. So negative 21 equals 4a minus c. All right, so in order to solve this system of equations, it's not like the last one where I had pairs that had the same letter. So what I'm going to do is I'm going to go ahead and solve this equation for b. So I get b equals 2c plus 1. And I'm going to put 2c plus 1 into this equation. And that will give me a top equation of 1 equals a plus 2 times 2c plus 1, or 1 equals a plus 4c plus 2, or let's move that 2 over, negative 1 equals a plus 4c. And we're going to combine this equation with this equation to find my a and c. Now I'm going to go ahead and multiply this equation by negative 4, and that will give me 4 equals negative 4a minus 16c. And when I add that to this equation, those a's are going to go away. I'm going to get negative 17 equals negative 17c, or I will get c equal to 1. All right. Now once I have c, I can find b. I know there's a lot of arrows going on, but once I have c, I can find b. So b is going to equal 2 times 1 plus 1, or b equals 3. And once I have b and c, I can find a. So 1 equals a plus 2 times b, and that gives me an a of negative 5. All right, so I've got a equals negative 5, b equals 3, and c equals 1. Let's put them into our answer. So negative 5 over 2x minus 1 plus 3x plus 1 over x squared plus 4. All right, folks, so that's it for our videos for 8.10, but when I post my final notes, I'm going to go ahead and make sure all the other problems are answered in case you wanted to do some extra practice. All right, thanks so much, folks.